And welcome back, my wonderful students. Let's do some kinematics. Now, this is a pretty important video, so you're taking a lot of notes on it. And when we say kinematics, we're talking about motion in a straight line. For example, forward, backward. We're not like kind of going at angles. So with this idea of kinematics, let's make a table together of all the different ideas we've discussed in this class that deal with motion. So this table of 3 columns, we're going to say the symbol, which we're going to see in the equations, the idea in words, which we're looking for, and the unit, which is next to the numbers when we look at the actual problem. The first major symbol we looked at is D, which stands for displacement. And you know displacement is how far, but more importantly, how far you are from a certain start point. And we know that's measured in meters. So if anything's just measured in meters, we know it's probably a displacement. We have to make sure, though. And always it's the positive or negative in front of it, or it's just some kind of direction. Then we have initial velocity, VI, which is how fast you're going at the beginning of some motion. So I think I said how fast you go at the start of a time period. It's in meters per second. For example, -4 could be one. So if we see meters per second, it could be initial velocity, or it could be final velocity. Final velocity is just the velocity at the end of a certain time period. And just like initial velocity, it's measured in meters per second. And the example would be positive or negative 114 meters per second. Then we have A, which stands for acceleration. We've talked about this a lot recently. You know it's really important. It's how much your velocity changes by every second. We know it's meters per second squared, so that's what we look for. For example, it'd be gravity. So if you see something in the air being dropped, you know the acceleration is -10. And finally, we have time, which is kind of like how long something lasts for, measured in just seconds, and it doesn't have a positive or negative. It's just a number. Now, all these variables are related by the 4 kinematic equations. These equations you're going to find on your formula sheet, so you always have them available for you. So let me write them in. The first one, VF equals VI plus AT. The second one, D equals VIT plus 1/2 AT squared. The third one, VF squared equals VI squared plus 2AD. And the fourth one, D equals 1/2 VF plus VI times time. So these all apply to all the situations. Now, each variable is missing something. We have 5 on our list. So if you go through and figure out which one is not listed in the equation, we can list the different variables that are not in there so we can't use it. The one that's in all of them is VI. So that's pretty important. So let's do a single example and see how we use our information, how we organize it. So I'm writing down a question about a panda moving. Now, as you're reading this and kind of writing it over, the whole point is that we can now calculate any one of those 5 variables if we know 3 of the other ones. So we're constantly looking at what we're given and figuring out what it actually means and how it relates to those 5 variables on the page. This is not just simply looking, getting numbers, and plugging it in. As you're going to see, it involves logical thinking and differences. So the scenario you have right here is a panda starts moving at some motion. After 2 seconds, it's going 4 meters per second. Then it accelerates for 6 seconds, covering 40 meters. What's its acceleration during the 2 to 6 second motion? And then finally, what velocity does it end at? So the skill you're going to have to do for me is you're going to have to underline the important numbers and ideas. 2 seconds, seconds is time. Meters per second is a velocity. Another seconds is time. You have a displacement in meters. You have acceleration A, and 2 to 6 seconds is the time. So you have a lot of times here. It doesn't make sense. Let's write down our table, variable and value. Okay, I have 2 times here, but we're looking at the time period. So it's from 2 to 6 seconds, which means it's actually a difference of 4 seconds. So that's our time period. 4 meters per second is at the beginning of it. So it's going to be VI because it's 4 meters per second at the 2 seconds, which is the beginning of the 2 to 6 second sequence. Displacement's 40 meters because you're going 40 meters from 2 to 6 seconds. Acceleration is unknown. It's our goal. And our final velocity is our goal as well. So we label them goal 1, goal 2. So to find the acceleration, looking at that list here, we're going to find the one that's missing VF because we want time, VI, D, and to have A as well. So it's going to be the one without VF, and that's the one I just pointed out. D equals VIT plus 1/2 AD squared. We're missing VF not because we want to solve for it, but because we want everything else but it. So looking at it, D is 40, VI is 4, time is 4 as well. Notice how I constantly go back, because if you just start looking at the original problem, you might put in time as 2 or 6, and that's not right. Now I could solve. 4 times 4 is 16. 1/2 times A, 4 squared is 16. Put the 1/2 and 16 together, you get 8. Move the 16 over. 40 minus 16 is 24. Divide, you get 3 meters per second squared. So we can cross out the acceleration, put the goal in there. So now we're going to go back and look for VF. But now we have many different things. We're no longer just limited to 3. We could use pretty much any equation as long as it has VF in there. So I choose the first one. You don't have to. You can choose another one that's got 3 of the 4 things we know. And finally going back, plotting in numbers. VI is 4, acceleration is 3, time is 4 seconds. We're going 2 to 6. We're going to have 16 meters per second.